Well, so back in 2014 I picked up this NCX-3 National and pretty much just put it on the bench and started using it. Didn't do none of the normal maintenance or anything that was needed. Radio did come from a working environment, so felt like, what the heck, we'll just run it. Now, the National NCX-3 is a 3-band radio. Covers 20, 40, and 80 meters. It does have, single sideband CW and AM, although AM is not even worth having in the radio. It only has one filter, so it's, you don't have the filter you need for AM in it, and it would be too much of a pain to go in there and try to modify it to make it work. But on AM, on transmit, you're only using one of the sidebands anyway, so still fixing the receiver up, you're going to have the problem with transmit. Now, one other thing on this radio I does not like is there's no CW side tone. So if you're using CW, you don't hear a tone at all. Only thing you hear is the little grunt from the power supply. So maybe that's something we'll have to look into trying to get going on this radio, is put a CW side tone oscillator in it, so that you can at least hear what you're sending. This radio, it's kind of entry-level radio. They designed it back in 1962, and it hit the market in December of 63. And they used a set of beam tubes, the 6 GJ5s for the outputs, and they're being driven by a 12BY7. So, it's not really a bad radio. It would be alright for single sideband, but it's a pretty decent CW rig. It'll put out a good 100 watts with no problem. The tubes are getting a little expensive for it, as far as the output tubes. They're out there, but people are wanting good money for them now. So you probably could rewire it and use a different tube in the finals if needed. I don't think it would be too hard to do, but right now these tubes are checking out pretty good. But anyway, I went to turn this rig on and had a distinct hum in the receive, so I know the capacitors are gone, and the receiver's down just a little bit, so transmit's working fine, but the receiver's down, so we know that it has some issues. One of the things that I have noticed, the chrome insert on some of the knobs are gone, so I'll have to look for a solution to fix those 4 knobs. I don't know if I have anything here in the shop that might have an insert that size, but a lot of the knobs have just got a flat plate that goes in it. These are raised, so I'm going to have to look around and see if I can find something. Well, we have the NCX-A power supply with it, so that's probably going to be the first thing we're going to start on, is getting that tore apart. And the old rig needs a good cleaning. You can see, it's got some spots on it. So while we got it tore down, we're going to do a good cleaning on it and see, can't we polish out some of that aluminum and get it back looking like it's supposed to. Other than that, the faceplate looks pretty good. It just needs good and cleaning. Here on the top, we are seeing some rust underneath. It's not, no heavy pitting rust, but there is some there. We'll need to work on that. I like to see if I can find a green paint that would match this, and I will go ahead and blast it and repaint it. There's like a couple of spots on here where somebody had something sitting on it for a while, but other than that, not too bad. I removed the case from the power supply, and you can see we got 3 transformers. Pretty good size high voltage transformer. And she's a little dirty. Needs a good clean up. There's one spot there I did a little polishing on here, and it's not going to be the best, but it'll come back to life. And as you notice, we got one metal can capacitor here, so we'll look at how we're going to replace it. I'm not sure if I'm gonna restuff it or just clip it loose, put a terminal strip and mount it underneath. And I think it would be very easy just to go ahead and mount a terminal strip here and connect the wires to the terminal strip and mount the new capacitor and ground it. As you can see, we got some old paper caps in here. There's 2 80 microfarad caps, and there's another 40 microfarad at 150 volt. These are 450 volts. And the caps that we're going to use are much smaller than these. So we'll probably come under here and mount a terminal strip and put on 2 new caps going to the terminal strips that's needed. And that's one thing about technology changing. This is 80 mics at 450, and there's the new 80 mic at 450. As you can see, it's completely different, a whole lot smaller than what these old paper caps were. So we'll probably just mount a terminal strip here and do away with these. Maybe move this terminal strip up here, and then we can hook the 2 capacitors in like this, kind of in a V shape to get them going. This one right here should be no problem at all. One terminal strip here, and then the other end just goes to ground. I'm sure we can pick up a ground somewhere else here on this other terminal. We'll need to check all these ceramic resistors and make sure they're in tolerance. And these are all rectifier diodes. If you've never seen them before. So the power supply should be pretty easy to go ahead and snatch this stuff out and replace that. Nothing hard at all about this. I might just remove this cap just to see how it looks on the other side. Let's see if it's has a crimp ring on it, or if it's completely expanded. If it's expanded, we'll just mount the new cap under here. And we also need to check this resistor that's on it also. So we want to take a look at our power supply. You can see our primary side coming in here, and we have basically 3 different sections on the transformer. This is our high voltage section. It's run through our bridge rectifier. That's those big 4 square diodes I showed you. And here we can see our first 40 microfarad cap at 450 volts. This is the cap that's inside the can, and this supplies our 280 volts out to pin 9 that goes to the transceiver. Down here off the bridge rectifier is where our 280 microfarad caps are, and we have 2 7.5 k ohm resistors. It's bleeder resistors on it, and that'll produce the 708 volts to pin 1. Off the small secondary is our 12.6 volt AC for our filament voltage. And then down here, this is our bias supply from our secondary, and this is when our 40 microfarad cap that's actually in reverse, the positive side goes to ground, and this comes up here to, I think it's pin 3. It's very hard to see on the schematic. But this is the only schematic I've been able to find on the power supply. It's pretty decent. Not too hard to read out on it. So one thing I do want you to note is that when these things were designed, they were designed for around 115 volts or 230 volts. My bench usually runs at about 122 volts. So our primary is going to be a little higher than what I normally, would be when they built this thing back up in the 60s. So running this on standard household current, you may see a little bit higher voltage on your secondaries and through your filtered and rectified. Now one thing I want to show you about quality control even back in the 60s. And like I said, looking at this, these look original. I don't think they've ever been replaced. See the screw protruding up from the bottom right into the cap, right on the end of it. And as you can see, this cap is banded down so it can't move. Also here on this 80 microfarad cap, you can see the screw down here that's dug into the cap. The same thing on that end. So yeah, it looked like National may have had a little quality control problem even back then. But the new caps will take care of all that. Okay, we got all our new capacitors installed. And remember the big 80 microfarad cap set in here side by side and was bolted in. So what I've done was move this terminal strip that was here down to here, and I've already exposed hole and bolted it in. And when I bolt these terminal strips in, I put a star washer underneath of it, and that's just to ensure it gets a good ground. The ground lead is not used on this little terminal strip, but it's there in case we need it. But our two 80 microfarad capacitors come from ground and are in series, and then we pick up a center tap here. It goes here. I put spaghetti sleeves on the leads and use some hot glue to secure them in place. We have our bias capacitor mounted, and the negative end goes to the wire and the positive end goes to ground. I disconnected everything off this capacitor and just bent the terminal over and mounted this terminal strip here, and ground is in the center, and I strapped through the holes with ground. So we have our resistor and our 40 microfarad capacitor mounted here and glued down. One thing I had to do was move the speaker wire. It did run down the length with all the rest of the wires. I just moved it over to the outside and used a little hot glue and tacked it down in place. Got that out of the way. I think it's best that the speaker wire is out away from all of these high voltage wires anyway, because it could pick up, and do some hum into the speaker. So it's over here next to the side rail, so that should eliminate any problem there. But yeah, but there we go. The power supply should be ready to go. I cleaned out from under the bottom, wiped it down with some isopropyl alcohol, and all I need to do is clean up the top and clean up the outside of the case. But other than that, our power supply should be ready to go. Next thing to do is start on the transceiver and get all the capacitors in it replaced. And pull out them old caps and put some good orange drops in. And as you can see, the bench kind of gets in a mess when you're doing something like this, so yeah, can't always keep it clean. So the last thing that we need to do to the supply is to get rid of this old cable. As you see, it's non-polarized, and it's been marked on the end which side is the hot, so we know this side is the neutral. And when you look into the power supply, you can see we got one wire that's tied directly to the transformer, and the other wire goes through this capacitor right straight to ground. So we need to eliminate that. So if you plug this in wrong, the chassis becomes hot and the transformer picks up the neutral, and we want to do away with that. So we're going to exchange it out with this 3-prong cable. Okay, so here we have the transceiver, and I've already got the top off of it, and there's only one electrolytic capacitor back here to place. Now this is a 3-gain electrolytic. That's 240s and 120 microfarads. The 240s at 350 volts, but the 25 mic is only at 25 volts. So we'll probably just go underneath here. And you can see there's the bottom of it right there. So we've got plenty of room under here to mount our 3 capacitors without having to restuff the can. So I've been through this radio and I've checked a lot of these old capacitors under here, all these brown capacitors, and I have them all marked, as you can see, with a yellow spot that are out of tolerance. Now the radio did lose a lot of its sensitivity, so it's going to be, you know, mostly capacitors and resistors that's just gone out of tolerance. So we have all those here, some orange drops that we'll be replacing them in. Now there is a design flaw in this radio that I want to show you. So on the front of the radio we have our PA tune control, and you can see there's a shaft that goes all the way through to this gain capacitor here in the back. Let me get a little better shot of this where you can see it. Well, inside you can see that gain capacitor, and you can see the rotor, and the rotor comes up and it stops. And what's happening is the design flaw is this rotor is actually hitting this top cover, and we all know that, you know, your voltage is on the rotor and your stator is mounted and grounded. So that was a fail on their part. Now I have talked to other people that has these radios, and what they've done, they've ran it without the cover on it, because as things weaken out and you have to tune a little more, you know, unmeshing the caps, you'll run out before you get fully unmeshed. So I don't like running the equipment without the covers on it. For one thing, you know, you want to shield your RF. That's the purpose of this cage, is to shield your RF inside of it. So there's not a lot of room up here on the top once the cover is put on the radio. So we might have about, I don't know, 4 millimeters or so clearance. So I may be able to come in here and put a little spacer around the mounts and just lift this cage up a bit. You know, another thing you could do is go ahead and cut this out and lift it up and put something, but I really don't want to cut the cage up. I like to try to keep it as original as possible, but I do want to try to eliminate this fail. Okay, so I have the cage off, and you can see the top of the rotor here, and I have the camera so you can see that this is directly going completely over top of the front plate. when it's fully unmeshed. So this is something I'm thinking is, you know, this is mounted with 3 screws in it, so maybe I can just rotate this around and perhaps have enough clearance under the bottom not to hit this other shaft that's here. And I may have to extend the wiring going to the stator plates. But that's just something I'm going to have to look into and see if it's even possible to do. But yeah, that was a big design fail on National's part. Well, I got the can capacitor disconnected and got it out. And I'm looking here, and you know that we got this resistor that's mounted to this terminal and to this 2 pin. And then we got this other resistor to 10-2. And I've been playing around with the idea of how to get these capacitors in here to look right. And I ain't really made my mind up yet. Because, you know, I do have one ground terminal here on this pin. So I could come in here and put a terminal strip here. But this is one of those capacitors that I was talking about in one of my previous videos, where you can peel up the outside of the can all the way around and pull this metal ring out and then pull the whole capacitor out. So, you know, our capacitors that's going in there are not very big. So that's looking at the width of it, you know, it's still under the size of the can. So these capacitors would slip up in there without a problem. And then our 20 microfarad at I think it's 20 volts. Yeah, 20 microfarad at 25 volts is a real small capacitor, so that would fit in there with no problem. So I may just go ahead and restuff this capacitor, put it back in there, and wear it back in like factory. And that'll look original, even though it'll be a new capacitor. Now, I did have someone mention before that, oh, you ought not restuff capacitors, it causes problems, you know, it's like a time bomb going off because they get hot inside. Duh. I mean, how about this capacitor? Wouldn't that be the same problem? No, they don't get hot enough. If nothing else, it would probably be safer, because later on down the road, if one of these electrolytic were to explode, it's going to explode inside of this. And it's not like this is going to be airtight, because there will be a hole drilled in it for the ground lead to come out to go over to the ring. So it would have a way to exhaust, even if it did blow out. So, yeah, that myth is busted. This would be more safer to have them inside this to just have them sitting under here. Well, since I have such limitations on mounting capacitors under here, I decided to go ahead and just restuff the old can with the 3 capacitors. And as I said before in another video, this outer shell is just crimped over on top of this metal ring. And all you got to do is take a pair of side cutters, and you can get in here and get one edge of it up. Then after you do that, you just take a little small old screwdriver. Don't use a good one. Use one that you can, don't worry about messing up. And get in here and slowly just work it around. And once you get it up a little bit, you can come back with a pair of needle nose and form this good and flat, so that when you go back to, you know, to make the crimp again, it'll look decent. I've now got the crimp completely opened up, and you're going to find some places where some of the aluminum's going to break off, and you don't worry about that. Now what we got to do is get this metal ring off. And we should be able to just lift up on it and pry it out. Now you can see there's our ground lug is attached to that metal ring. Just go ahead and break that right off. Now we can take this piece and clean it up, get the scratch marks back out of it that we put in from prying out the can. Next thing to do is heat this up. I'll do this outside. Put an oven, get it good and hot, put an oven mitt on, take your pliers, grab it by one of the terminals, and you'll be able to slide it right out once it's hot. Well, as you can see, our capacitor is completely apart. And I'll put some gloves on and I'll go outside and unwound all this old capacitor off and clean this up, and then we'll clean the can up. And I'll take a large socket and find one that fits just in the bottom of this can, so I can re-roll this here back round and get it good flat like it's supposed to be, and you know, get the inside cleaned out, and then we can start putting this capacitor back together. So there you go, cap's all cleaned up. I just got to reform this around, and these leads here, you cannot solder to them. They are aluminum, so what we'll do is bend them all over like so, and then we'll cut them off about 2 or 3 millimeters, and this will give it a little action, you know, keep from pulling the pin straight out. And when we bend them over, we'll glue them down to this. You can see this slot here is where the ground bus for the inside capacitors came through, and it would come out here and fold around the can, you know, and then crimp to the top and to the ring. What we'll do, we'll just run a wire through the side and solder it directly to this ring. But there we go. I've taken a small circuit board drill and I've come right down next to the inside of each pin and drilled a hole all the way through, and then clean the stuff, you know, that come off out. And what this does, this is raw 47 microfarad capacitors. This gives us a way to bring that on up so it can be soldered right to the terminal. We'll have to get the spacing in there just right so they'll sit side by side. And now see, we can wrap these around the terminals and solder them in place, and then take some hot glue and hit the capacitor and fill in under the bottom to hold it in place so it won't be vibrating around. And as you see, the capacitors fit inside the can with no resistance at all. Okay, I have all the capacitors mounted, as you can see in there. What we do, just bring them up through the hole, wrapping around the bottom of the lead, and solder them in place. Now what I'll do is take some hot glue and come in here and glue all the capacitors together. Then I'll fill in this gap down here at the bottom, and that'll hold the capacitors rigid to the support. Then I'll see, there's a hole right here. I'll drill this hole out. I'll bring a wire up, and we'll bend all these over and attach it to our ground, and then we can put our capacitor back together. someone mentioned before what kind of capacitors I'm using. These are MIEC, and they're from Just Radio. Yes, they're an overseas made capacitor, but I have found that they seem to work very well, and I have yet had one of these failed, and I've been using this company for a right good while. No, it's not the name brand, but I have found these to be some very decent capacitors. Well, the capacitor is just about ready to go back together. Got it all soldered in. Got the ground wires together. Put this piece of tape across the back of it and held it this way, and just flooded the whole bottom with hot glue. And was letting that sit there and dry. I'm going to let it dry for a few more minutes till I can pull the tape off. Then this unit will be ready to go back into the can. Well, the capacitor is all back together now and ready to be reinstalled. And you know, you're not going to get a very nice looking crimp on it, but it doesn't matter because all that's hidden inside the chassis. As long as the outside edge looks good is all that matters. So what I'll probably do is print out a new label with today's date on it and what's in the can, and glue it to the can, and then clear coat over it. But yep, she's ready to go back in. We have a capacitor reinstalled, and I forgot to mention earlier, if you look right here in the center of the can, I drilled a small 1/16 hole right here in the center on the top. And the reason why I did that, if one of these capacitors go bad in the future, it's got a way to vent, and they can vent right out the top of this can. Okay, so this time we have the capacitors installed, all the electrolytics right. But you'll understand that at the end of this video, what I mean by right. Anyway, we're going to fire the rig up. I've already tested the power supply to make sure that all the voltage was right and everything looks good. Let it warm up. And one thing I have noticed is that the S meter is not working. It worked when I first got it, and then it quit. Okay, I won't get no volume out of it now. I've already cleaned this potentiometer, but I'm just moving it up and down. So look, I'm going to have to take it apart and see if I can repair it. If not, I'm going to have to find a way to replace it. Now this is a dual gain potentiometer. But anyway, I'm injecting quite a bit of single into it. And as we see, the S meter is not working at all. And I've even turned the single up more. And we're in the AM position because our 8640 does not do single sideband, it does AM FM. So here's a little tip for checking the S meter. Now we can go ahead and say, okay, something's wrong with the circuit. You know, we'll go in, pour the schematic. There is no service manual that I have ever found for this radio, by the way, although we do have schematics. So what we're going to do is take this little box. This is just a S meter out of a I think it was a Cobra 29 or something, and it's mounted in this little box with terminals. Now it's not going to match the circuitry here, but still we can test to see if our S meter is working at all. And all we're going to do, we're going to connect the ground, connect to the hot. We'll come to the back of the radio, the back of the meter, and do the same thing. And as you can see, it completely peg the meter out, I'll turn the RF gain down. And we can see that our meter circuit is working. So what this tells us is that our meter itself is not working. So we want to look at that and see if we can figure out if the meter is stuck or if the coil is open inside. Okay, I've removed one wire from the terminal on the back of the meter. You don't have to take both of them out. We're just going to use an old analog meter. Let me get this so you can see the meter. And what we're going to check is just, you know, check for continuity. What that shows is that our coil is not open. Or at least we're thinking it's not unless there's an internal resistor or something inside the meter. But this is showing that our coil is not open. So that's a good sign. So maybe it's just the meter is stuck. So right here in the middle of the schematic is our S meter circuit. Now we do know that the S meter is not working on this radio, so we may have to go in here and follow through this circuit and check it out. But the first thing we do before we do that is check out this meter and see if the meter is even working. And you can see our S meter there and the calibration part right beside it. Okay, since we got the meter out, we just had to move the 4 screws on the back of it, you know, take the terminal wires off, and we're able to pull the meter right out. Now's a good time to, you know, if we can get the meter working, to get it good and clean and polish out the front of it. Well, there may be a few scratches in it. And what we're going to do is go ahead and open it up. And you want to be very careful with these old meters, because you can crack them easily. There's 2 tabs here at the top, one here and one here, and it's hard to see, but trust me, they're there. And there we go. The meter come right out. As you can see, the face of it looks very good. Now we want to see if this meter is stuck. And it is not. The meter is moving freely. Alright, I'm going to have to get this in the back and tear it on down and check in the back and see what's going on. I got our meter out of the case, and when you do this, you know, you need to handle this very carefully. Don't hand it by the front. Excuse me. And I got 2 wires attached to the meter circuit. Hang on just a minute, please. Okay, I've been coughing up a lot of that stuff here lately, and if I connect the meter directly to the terminals, you see nothing's happening. So what I'm going to do is bypass this terminal and go straight up here to this wire connector. Nothing's happening. Now what I'm going to do is take the ground loose from the stud and just go right to the magnet itself, or to the housing, and boom, look at that. Our meter is now working. See if I can find a good place to clip on to, so we can verify that the meter is working. And I can go to the RF gain and now adjust the meter. So what's causing this? Let me shut the radio off. Excuse me. Okay, these brass studs, you see they go through and they're connected in through this piece of plastic board here. And what's happening is these connection in between here and this ground has become corroded. So we're going to have to easily work this off and clean these connections here. Okay, this is our grounding bar here. And I'll slip this stud out. And we can see a little bit of corrosion around this terminal here. And also under the head of these bolts. So I'm going to have to go ahead and clean all of this up. I'm going to do that off camera. And we'll get that cleaned up. We should have some ground in. Okay, I got all the terminals cleaned and the studs put back in. It's a little bit delicate work, you got to be careful. And now you can see our meter is working like it should be. So here's a little trivia for you to see who is listening, who's fast forwarding through the video. Why does the negative side on a DC circuit corrode before the positive side? I'd like to hear your answers on that. You know, it can be, even if you look at a car battery, most of the time you'll see the negative terminal corrodes first. Anyway, I'll get the plastics cleaned up and get the meter put together and get it back in, and that part should be working okay now. Well, the radio is all together. And I'm sitting here tuning across 20 meters. Which is not the best today. I'm picking up a few singles. Surprised how bad the bands has been lately, but they have been terrible. I checked the transmitter a moment ago and we're putting out a good 100 watts. Tuning on this radio is a little touchy, and if someone ain't long-winded, by the time you get tuned in on them, they've already quit talking, and that's just a characteristic of some of these old radios.
Really made it a lot of fun for us. Conditions were good on 20 and from and 40 was okay. I was very surprised that 80 meters last night was not happening at all.
Another thing that you won't find on this type of radio is a noise breaker circuit.
I'm hoping the band's slowly starting to improve as time.
something we can add later on. We're going 40. We'll tune the exciter. Figure 40 will be about dead this time of day. And I was correct. Anyway, the radio is basically working. As I said before, there is no service manual available. We do have a schematic. So what I'm going to do is call this part 1 of this radio. The radio is back working like it should be, and the receiver is back up. So in part 2, what we'll do is go in and do some alignment to this radio. Again, I usually don't show people how to do an alignment because that's just boring stuff, but since I have not been able to find a service manual on this radio, I would go ahead and go through some of the tune-up procedure in it, so that those of you that have these, you know, will have something to go by. We'll also in part 2 look at this PA tune capacitor and see if there's a way that we can eliminate it from hitting the cage. I'm really thinking about going in there and rotating this capacitor around to the next set of holes, which I'll have to move the wiring on the back of it and extend it, but I believe that will be doable. I really wanted this radio fixed since it's 20, 40 and 80 meters for CW. Again, it's not much good on AM at all, but it will do real good on CW. The only downfall, as I said earlier, there's no CW side tone, so we'll look at see if there's a way we can install a CW side tone board in here so that we'll have a little noise when we're using CW, so we don't have to listen to just a transformer grunting. Anyway, hope you enjoyed the video. I'll leave links down below under the show more tab if you like to contact me, or I'll also leave a link to the website if you like to discuss it, and we'll put some of the schematics and up in that thread also. So again, hope you enjoyed it. If you did, give me a thumbs up. We can always enjoy that, and it helps us a whole lot. So until the next time, we'll catch you on this one in part 2. Okay, now that we got our cap installed, I'm going to go ahead and check the voltage on that. I've already checked the voltages on the power supply. I fired it up manually and that looked okay. So the voltages look good coming in. We just have to worry about the voltages here on the capacitor that we restuffed and put back in. So I'm going to go ahead and fire it up. Uh-oh. Well, that was a failure. Let's find out what happened. Okay, so anybody want to guess what this is? This is a 20 microfarad 25 volt capacitor that we put inside the can. And when I was rearranging this, you know, our can has 3 legs, and I even have a, yeah, here it is. Okay, so originally we have a 40 at 350, a 40 at 350, and now a 20 at 25. But since I restuffed the cans, it was a lot easier to put the 240s on the outside and put the 20 in the middle, because that gives it better support holding the capacitors in the can. And I even made a note of it here, 40, 40 and 20. Well, when I wired it up, I wired the 20 over here and the 40 over here, which means I put 350 volts on this 25 volt capacitor, and that was the failure of doing that. So, you know, I'm just keeping it real. You know, even I make mistakes, and I just want to show you that I'm not beyond doing it myself. So, yep, my first blooper, and I'll add this at the end of the video. Anyway, hope you enjoyed the smoke show.